The title of my talk is What Do Theories of Consciousness Predict About the Onset of Infant Consciousness? And this talk is related to a project that is funded by Templeton Award Charity Foundation. And in this project, I focus in the theories I will discuss here. Global workspace theory, higher order theories, recurrent process theory, and IIT. The project is broader than what I will present in this talk because it also involves animals and machines, involves entities that don't have verbal report, and entities where just behavior markers and neurobiological signs of consciousness might not be sufficient for know if that entity is conscious or not. Okay, so in this project, I examine leading theories of consciousness, and I think the project tries to understand is relevant to understand the theories, but also making progress in the problem of infant minds. Is relevant to understand the theories because you can also use those cases, animals, infants, and probably nowadays machines, to test the theory. What are the predictions of the theory? And if the predictions correlate to what we also find from other source of information, we might increase or not our confidence in the theory. Okay, so the problem of infant minds is a version of the problem of other minds. So how can we know whether infants are conscious? We know that we cannot just rely on observation in the case of consciousness. Usually in adults, we rely on verbal reports, but we cannot rely on verbal reports in the infant case, but also animals and machines. So how can we know if infants are phenomenally conscious, if they are having subjective experience? So when I mean if infants are conscious, I mean phenomenal consciousness. So this is a problem that raises in other cases. So usually we call this the distribution problem, how consciousness is distributed among different entities. Are machine conscious? Are animals or fish conscious? Nowadays, we're more inclined to think that fish are conscious. But so the big question nowadays, insects are bees conscious? Are cerebral organoids conscious? Patients in comatose states conscious? And are infants conscious? So infants is a particular and an interesting case because we know that at certain point they will become conscious just because from our own experience as adults that we are conscious. So the question is when consciousness emerges and what kind of structures are necessary and sufficient for consciousness. Okay, so when does consciousness emerge in infants? So I usually present this as a way to reply to this question as a dilemma. So we cannot use first-person methods as introspection and verbal report as we use in the case of adults, but also in the case of animals. We can train animals to give us some subjective reports of their subjective experience. So if you cannot use those measures to measure consciousness in infants, we know also that third-person methods alone would not be sufficient for determining if infants are conscious or not. So which methods can we use? So I suggest something that is very, that has been used also in the animal consciousness literature, a kind of a combination of first-person methods and third-person methods from both the adult human and the infant case. So, and once we combine the first person and the third person methods, we can, from inference to the best explanation, determine if the markers of consciousness in the adult case are present or not in infants. So my suggestion is, first we start with observation of correlations between consciousness and behavioral brain processes in adult case. And once we establish those correlations, to explain those correlations, we infer underlying principles that connect consciousness to brain and behavior. From this, we isolate neural and behavioral markers of consciousness, and we can test if infants have those neural and behavioral markers of consciousness. Through the inference to the best explanation, you can say, okay, this is the best explanation of what's going on, or if you observe that behavior or that neural marker of consciousness, that infants are conscious. So two approaches we find in the literature. One is behavior and neurobiological signs of consciousness, and the other theories of consciousness. So what are the sufficient and necessary conditions theories of consciousness will propose as a marker of consciousness. I want to discuss the first approach, the behavior and neurobiological signs of consciousness. I have a paper on this. I will focus today, because I think for this audience, theories of consciousness would be more relevant. So I'll focus on the second approach, that is philosophical and scientific theories of consciousness and what they predict about infant. Which theories? The theories I'm interested in, the theories that posit some specific correlations between physical processes and consciousness. So I will discuss higher-order theories, integrated information theory, global workspace theory, and recurrent processing theory, although I will focus those markers on global neural workspace and recurrent process theories. That's because I think I had more interesting things to say about those theories than the others. So I'll go very briefly to higher-order theories and IIT, and spend more time in global workspace theory, and spend much more time in the recurrent processing theory, because I think there are some interesting new experimental evidence that might be relevant to think about the infant case. Okay, so first, high-order theories. So usually the way to understand consciousness among the high-order theories is a relation between conscious states and high-order representations of that state. So there is a first-order state, and there is another state that represents that state. So a phenomenal conscious mental state is a mental state that is the object of a higher-order representation of a certain sort. And the higher-order theories come in different versions, have higher-order perception theory, higher-order thought theory, and self-representational theory. I'll just say a little bit about the higher-order thought theory and the self-representational theory. What would be their predictions regarding infant consciousness? Okay, so higher-order thought theories, as I said before, a phenomenally conscious mental state is a state which is the object of a higher-order thought and which causes the thought non-inferentially. So there is no evidence that infants have this high-order thought that make the first-order mental state conscious. So if they don't have this structure, this state that represents the other state, the theory will predict that they are not conscious. Okay? One way to accommodate this theory, there is one version of this theory that is more friendly with infant consciousness proposed by Rocco-Gennaro. The idea that maybe this high-order thought is a kind of primitive concept that even infants can have. So sort of a demonstrative concept. So if I'm in pain, there is a demonstrative thought, this or this pain, that makes the state of pain conscious. And if they are right, we can say that this would enable infants to have primitive forms of high-order thoughts, and then to be conscious of their experiences. Okay? Self-representational theories, I don't think this theory pose any problem for infant consciousness, because the self-representation thought does not need to involve concepts. Okay? So self-representational theory says a phenomenal conscious state is a state which represents itself to the person who is the subject of that state. As I said, there is no concept necessarily involved. So infant may possess this kind of non-conceptual self-representation, which requires just like a kind of minimal metacognitive abilities. And there are in the literature some empirical evidence that they might have these very minimal metacognitive abilities. So if it's so, self-representation also allows infants to be conscious. It could have a prediction that infants are conscious. Okay, so now IIT. Let's see how the theory is formulated and what would be the prediction of the theory. So according to Tononi's information integrated theory, consciousness is identical to integrated information. A mathematical measure phi represents conscious experience and derives predictions about which circuits in the brain are necessary to produce conscious experiences. So consciousness varies in quantity and comes in many degrees, which correspond to different values of this measure. And it aims to explain the quality of consciousness. Phenomenal consciousness is determined to be the totality of informational relations within the relevant integrated complex. Okay? So what is the prediction of the theory regarding infants? So it's highly probable that even newborn infants' brains have some degree of integrated information, and that the infant's brain will have phi higher than any subsystem of the brain. And if so, IIT will also predict that newborns are conscious because their systems present some degree of integrated information. But curiously, the theory also can predict that probably infants are less conscious than adults due to the low level of information relations within infants' systems compared to the case of adults. Okay? So although the theory can derive the prediction that they are conscious, they might be less conscious if you adopt the theory as the explanation of the theory of what is consciousness. Okay? Okay, so this is very simple what I have to say about higher order theory and IIT. I'm just get the main definitions of the theory and how we could apply in the case of infants and what we know about the infant's brain and behavior that might be compatible with the predictions of the theory. Okay, now global neural workspace theory, and then later I'll say a little bit more the recurrent processing theory. And for those theories, I will engage some empirical evidence and discuss the empirical evidence for the theory that we'll see that pose some problems for infant consciousness, and what is my interpretation of the experimental paradigm. Okay, so global neural workspace theory. The idea of the theory is that the brain has a global workspace involving both sensory and frontoparietal areas associated with attention. So an entry into the global workspace allows information to be broadcast, and this gives rise to consciousness. What we subjectively experience as consciousness is the global availability of this information. Okay? In the Hans mod of the theory, and I put in parentheses, maybe this is a sort of old version. I'm not sure if he's still endorse everything I'll say, because might involve the measure of the P300 that probably has been debated a lot in the literature. But okay, I will discuss the evidence considering his sort of old model. So in this version of the theory, a stimulus propagates into the cortex is consciously perceived when the threshold of awareness is crossed, and this threshold that is crossed correlates with a specific type of electric activity. That is this P300 slow wave brain activity that correlates with awareness. So P300 in adults correlates with verbal reports of consciously perceived stimuli. Okay. So if the theory is right, P300 is a necessary and sufficient condition for consciousness. So the lack of this neuromarker means lack of consciousness. In a study in 2013 by C.D. Kuder and collaborators, they tested if infants have this P300, okay, if this wave of activity shows up in the when an infant is perceiving faces. Okay, so what they found, I won't have time to go in details, but I can go in the Q&A in details of the study. But what is relevant for a purpose, they were trying to see, we know that infants are attracted to faces, okay? So if the infant spends some time looking for the face, is an indication that they are seeing the face, or they're seeing the stimulus, and they're trying to see if this would correlate with the same type of measure we find in adults in the case of infants. And what they found is by 1 year, infants display a strong P300 response. 5-month-old infants display a weak and a variable P300 response. Earlier than 5 months, there is no evidence that infants display P300 response. So, if infants don't display this P300 response, what would be the prediction of the theory if the theory endorses that the P300 is a necessary and sufficient condition for consciousness? So if infants shows the P300, then the model will predict that they are conscious. If infant shows no P300, the model will predict that the infant is not conscious. So they found that infants present from 5 months old the P300, but they're not present the P300 before then. Okay, so we can conclude from this that infants earlier than 5 months don't have the P300, then they are not conscious. Okay, so the question is whether this P300 is a reliable mark of consciousness. There will be that has been lots of debate in the field trying to refute this idea that P300 would be a marker of consciousness. So it's controversial whether P300 would be necessary and sufficient. So in a paper in 2016, Christoph Koch and collaborators, they argue that P300s have been found in patients, in comatose patients that probably are not conscious, and probably is not even necessary. So there is a finding from Michael Pitts that argues that the P300 is absent in subjects who consciously see a stimulus without performing a task. So one way to understand this is that many theories nowadays probably will reject this P300 as a mark of consciousness, probably even the hen. Okay, maybe one way to, I can say a little bit more in the Q&A, if infants don't show the P300, this might be an explanation of a different type of conscious processing they have, then the idea that they lack completely consciousness experience because they don't have the P300. But I can elaborate more on this if anyone wants to discuss the P300 marker. Okay, so one question, can there be a less demanding version of a global workspace theory where it does not involve necessarily the P300 that might be related to cognitive tasks that comes together, or our capacity of reportability that comes together when we are seeing a stimulus and reporting a stimulus. So a question would be there if we could have a global workspace where sensory of consciousness doesn't require those higher level cognitive capacities, okay, that would correlate with our capacity for reportability, okay? So, for instance, a kind of global workspace that is related just to flexible actions, to control of actions, and not control of verbal reportability. So a less demanding global workspace theory would be probably consistent with infant consciousness, because we know from the development of a brain that infants will develop cognitive areas later, and the sensory and motor areas are developed earlier. So if global workspace could be compatible or a kind of availability just for flexible actions, this could be a way that the theory could come with a prediction that would be more compatible with newborns. So one way to understand this would be newborns might have a global availability of information for controlling their actions, even if they don't have too much motor control, but they have some kind of control of actions, first in the mouth area, and then later on hands and limbs. But there would be a kind of global availability that would be not correlated with those complex cognitive capacities. One important distinction here would be distinguish between awareness and reportability. So reportability is sufficient for conscious, but might be not necessary, and infants might not have this reportability. It's even hard to train them to give some subjective reports, as in the case of animals. So if this distinction holds, we can say that the pre-300 wave might be a kind of neuromarker of reportability that correlates with cognitive processes where this cognitive process is not present in infants. Then we would need a criterion that would be a criterion that distinguishes between our awareness and reportability. And maybe if you find certain types of brain activity that correlates with this awareness without reportability, we might find a strong case if you find this measure in infants. Okay, so this would be a kind of challenge for theory to come with what would be the type of neuroactivity that would correlate with awareness in the case of with awareness without reportability. Okay, so I'll spend more time now with the recurrent processing theory, because I think there are some more recent interesting findings that can challenge the theory in an interesting way. Okay, so recurrent process theory, RPT. So here is a very broad formulation from Victor Lam. So RPT holds that certain localized recurrent neural processes in sensory areas are necessary and sufficient for phenomenal consciousness. So it's a sort of first-order theory. We don't need a high-order thought to make the first process, the first mental state conscious. And you don't need to broadcast for different general systems in the brain to be conscious. What you need is a kind of recurrent process that can be local in visual areas. So high-order cognitive processes are not required for sensory consciousness in this view. So the start point is much more friendly with infant conscious than all the other theories we saw so far. Okay, so here is just a way to represent how the theory understands how the information navigates in the brain. So it starts with a visual input that is unconscious in 40 milliseconds. This visual input navigates a little bit more, travels around the brain, and in around 60 milliseconds it's still unconscious. And at 100 milliseconds, we start some recurrent processing that makes the visual input conscious, okay? So you don't need any global broadcasting of the stimulus. What we need is these recurrent loops that would make the input conscious, okay? So according to Llama, this feedback, this recurrent process, this feedback is necessary and sufficient for consciousness. And when we have the presence of those processes, it makes the system conscious of the stimulus. Okay. Okay. So what is the prediction for of the theory for infant consciousness? So RPT predicts that if infants conscious vision have conscious vision, if and only if they have those recurrent visual processes, okay, that and the other relevant background conditions that the theory postulate. But what will be relevant for us is if they have or not those recurrent visual process. Okay. Okay. So we have an interesting experimental evidence showing that infants might not have those recurrent process. So a paper from by Nakashima in 2021, they found evidence that infants under 7 months are immune to object substitution mask. That is an important process to show that the recurrent processing theory is the right explanation for consciousness. Okay, so usually the fact that we are susceptible, adult consciousness, and even animals are susceptible to object substitution mask is regarded as a sign of consciousness for the theory. Okay, so if infants don't have this recurrent processing, or if they're immune to visual mask, this might suggest that recurrent process in infants is either diminished or completely absent. And if the theory is correct and the theory predicts that recurrent processing correlates with consciousness, conscious vision in infants would be either diminished or completely absent. And this would imply something much more radical than the global, the first finding we have for global neuronal workspace, that was infants by 5 months. This would be like even for 7 months would not be conscious at all, or at least not have any kind of visual or auditory consciousness. Okay. Okay, I thought it would be for this audience a little bit just to background to understand how the experiment with infants were conducted. So, the idea of the visual backward mask, they usually use it in the science, in the visual science, to study how visual perception is processed in the brain. Usually, the way to understand is if you have a visual input and you disrupt this visual input with a new other visual input, this second visual input depends on the delay that the visual input is presented, will disrupt the consciousness of the first visual input you have. And the best way to explain this disruption is to understand that the visual input is traveling around the brain, and there is a recurrent processing that comes, and this recurrent process that will make that visual input conscious. And the object masking disrupts this recurrent process. Okay. So here is just the way the experimental paradigm is designed. So you have a stimulus. You see the C with 4 dots. So you present first a screen with no object masking in the no stimulus in the second screen. And then we present another screen with those 4 dots that will disrupt the vision of the first object we have in the previous screen. And when we have this disruption that corresponds to the emergence of the recurrent process in the brain, this disruption will make the first input unconscious. Okay, so there is this disruption of the feed-forward process. With only feed-forward process, backward masking would not occur if you just have like a feed-forward processing. It's because you have this recurrent processing that it's possible for us to disrupt, to have this effect of disruption of the first stimulus. So visual backward masking is thought to occur because the second stimulus interferes with the recurrent process of the first stimulus. Okay. Okay, so with this information, let's go back to the infant case and see how we can show that if this recurrent process is present or not in infants. So what Nakashima and colleagues are trying to do is apply this backward masking in infants from 3 and 8 months. And what they found is that at certain age, they still don't have this kind of recurrent, not the recurrent process, but they're not still susceptible to backward masking. Okay, so here is the methodology they used. So again, they use face perception because infants, as I said before, they are attracted to faces, so you don't have to train infants, and it would be impossible if we try to train them. You cannot condition them to look to certain areas of the screen or to react to some specific stimuli, but they are naturally attracted to faces, so we can use this capacity to try to see or to test them with certain experimental paradigms. So the first condition just present the face. You can see that we have like 4 faces, 3 of them as scrambled faces, and 1 that we actually you can actually see a face. And infants are naturally attracted, and we can use looking time paradigm to see that they are attracted to this area of the screen, and they spend longer time looking for this, longer looking for this area of the screen. Okay. So the first condition, there is no mask, and the second condition, we present a mask. And what they found is that infants at age of 7 and 8 respond to the mask, but before 7 and 8 months, they don't respond to the mask. Okay, it seems that they're still seeing the face, although there was a masking to disrupt that stimulus. So the time they're spending looking, both conditions are the same, as if they're still seeing the face. Okay. They try to. There are some discussion if those conditions actually show that the infants are seeing the face. So they have some other control conditions trying to actually show that the infants are seeing the face, and they are also seeing the mask. So there is one condition that without the face, just the mask. There is another condition that they, I can say a little bit more of those conditions in the Q&A if anyone wants to go, but there is another condition, another hypothesis that maybe what was happening is that just 4 dots, those 4 dots weren't, although it's enough in the case of adults to get the effect, maybe you would need some robust masking for infants. So they use this, the circle to try to have a kind of a robust masking. But the effect was perceived even if they tried to, they could show that infants were still perceiving the faces, even if they manipulate with other conditions. Okay, so one question is, do infants see more than us? Because they are seeing, there is one object that is disrupted for us, and we don't perceive the object, or infants after 7, 8 months, and adults. And infants earlier, they can see this object. So one interpretation could be, okay, maybe they are seeing more than us. Or maybe they are not seeing at all. They are completely unconscious perception, okay? So we can combine this. I'll just say a little bit about other pieces for the puzzle that the paper uses to come with their own interpretation, and then I will discuss the prediction and and I'll come with my own suggestion for how we can understand the predictions of the theory. So another thing we know is, so no backward mask in infants under 6 months might suggest that they either have diminished processing or they don't have recurrent processing at all. In addition with this, we can combine with anatomic evidence that the infant brain develops the areas or this type of recurrent processing later. So in the beginning, the recurrent processing is immature, earlier than 6 months, okay? And the specific type of feedback that is presented in the adult case that Victor Lam thinks and that is crucial for consciousness is exactly the ones that are missing in the infant case, okay? So the layers that are relevant, that the recurrent process theory thinks are relevant, because there are different types of recurrent processing in some these local areas of the brain. And the theory thinks that there are some specific types that are relevant for making the stimulus conscious. Okay, and those areas are specific, the ones that are missing, or they will develop this type of recurrent processing. Those layers will develop later. So you can combine this with the infant, what we know about the infant brain regarding recurrent processing, to make the case that exactly what the theory predicts as a necessary and sufficient condition for consciousness is the ones that are actually missing, okay? Okay, predictions. If infants lack the relevant recurrent processing, the theory predicts they lack visual consciousness. So I will suggest 3 interpretations. First, infants are conscious and the theory is wrong, okay? So we don't need recurrent processing. It's not necessary or other necessary sufficient for consciousness. Other interpretation, infants lack visual consciousness. Another interpretation, infants have some kind of diminished recurrent processing that would be consistent with immunity to object substitution mask in their age, okay? I will not discuss the first interpretation because I'm much more concerned with the predictions of the theory. So I don't want to, at this stage, to falsify the theory and reject the theory. So the first interpretation is at least less relevant for my purpose here. So I want to see if there is a way to accommodate the intuitions the theories have with the infant case. Okay, so second interpretation. So the second interpretation is that the theory is right and infants lack visual consciousness. So if object mask does not work with infants, it's because they don't have recurrent processing. If recurrent processing is necessary, infants lack visual consciousness. I think this is one possible way that the theory can try to bite the bullet and deny that infants are conscious. It seems to me a little bit extreme and implausible because this would require deny actually that extended looking paradigm involves conscious perception. So most of the developmental psychology that has been doing with early stages is using looking time paradigm. So we would have to deny that what we have been studying the last 30 years using looking time paradigm, thank you, was actually that involved any kind of conscious perception in the case of infants, okay? Because the methodology that the study used involves the looking time paradigm. So if you think that when infants are looking longer to the face with the masking, if the infants are not looking, if infants are not conscious of the stimulus, just like unconscious perception, this would mean that every time that the infants is looking, that we are using looking time paradigm, this might involve unconscious perception from the at least 7 months of life or 7 months of life. Okay, I mean it seems implausible, but I don't want just just based on this. There is a way that the theory might explain this, might try to accommodate this. Okay, so if this is possible, is plausible. So how the theory could explain? Okay, maybe we just have unconscious perception until 7 months, and the best criteria we have to show that infants are conscious is that they are susceptible to mask, as we do in the case of animals. If they are not susceptible to mask, they are not conscious at all. So how they could explain why infants are looking longer? There is an alternative for the theory, although I think it's implausible, but there is, and this is Victor Lam's attempt to explain how this could be accommodated. So one possible explanation would be that the infants, they come hardwired, they are born hardwired with the capacity since birth to look as a kind of mechanistic process to look to faces. So areas dedicated to look to faces. And that signal probably amplifies, get amplified via recurrent process when they are, the recurrent processing emerge during brain development. So mature babies have this effect amplified because they have the hardwired to look for faces, and they have the amplification with the recurrent process. And what happened with the young babies, they have just the hardwired, the mechanistic process to look for faces, and they don't have this amplification of the recurrent process. And the prediction, if this is right, the prediction would imply no conscious perception until 6 months. I would say until 7 months, because the study shows that you need, some babies would be in 7 or 8 months. It seems to me a long period of life without no conscious perception. So I would try to have a more optimistic explanation, that I think might be more plausible. Okay. Okay. So this. So the third interpretation is that comes with this sort of explanation. So there are multiple sorts of recurrent processing. One sort is disrupted by backward masking, and this sort is absent in infants until 6, 7 months. Okay. However, they have other sorts of recurrent processing that might be completely unaffected by backward masking, and maybe what are their conscious processing they are having, they are using those unaffected recurrent process that are not susceptible to backward masking. And if this is right, this recurrent process would support consciousness in infants. And this is compatible with what Victor Lam says in his paper from 2007, that acknowledged 2 types of recurrent process, an early and a late recurrence process. So it makes 2B reentering processing that is interrupted, but a later stage in between visual and higher high brain areas, whereas early brain processing within visual areas goes uninterrupted. So he also admits that we might have those early processes that are uninterrupted. And a suggestion would be that infants, what makes infants conscious or have visual conscious perception are those early recurrence and not the later one. And the early one, we know they are not susceptible. They are not interrupted by masking. Okay? So suggestion, object substitution mask disrupt later recurrent process, but not early recurrent processing. Young infants lack late recurrent processing, but have early recurrent processing. Early recurrent processing is sufficient for consciousness. And then with this, we can accommodate infant consciousness. Okay, a problem. Okay? If this explanation that I'm suggesting is possible, so why object max doesn't disrupt early recurrent processes in the case of adults? So if this is right, why if infants just have the early process, not the late one, but adults have the early and the late one, why object substitution mask is not disrupting the early process in the case of adults? Okay. So if this is right, why adults don't see the masked objects in object substitution mask? Because maybe their late process was disrupted in the adult case, but they could use the early recurrent process to be conscious of the stimulus, and this is not what happened. So this explanation also have to explain why this not happen. This is a hypothesis, as a suggestion. So one possibility is that the object substitution mask first disrupt late recurrent processing when present in adults, and this disruption of the late recurrent process might, in the case of adults, disrupt the early recurrent processing in the case of adults. So adults won't have an early recurrent process to make the stimulus conscious, because probably both will be disrupted. Okay, so this is a hypothesis. I don't have any evidence to confirm. I don't know, maybe someone in the audience can come with either something that refutes completely this hypothesis, or something that might be, if the hypothesis is promising or not. This interpretation suggests that states of visual consciousness in young infants lack later recurrent processing, and therefore may have a different structure than later stages. Okay, so if this hypothesis is right, I still have to explain what type of structure of visual perception infants have, because if they are just use the early recurrent process, probably the type of the vision processing they have is completely different from adults, or at least a little bit different. Okay, conclusions for recurrent processing theory. Once we note the distinction between early and late recurrent processes, RPT and backward masking results may no longer predict that young infants lack conscious vision. However, if young infants lack late recurrent process and their early recurrent process are immature, their conscious vision may be quite different from the vision in older children. There is also a still open question, but I will skip this question because I'm running out of time. One final question: are baby more conscious than us, as Alison Gopnik suggests, because they are not vulnerable to masks? Or are infants less conscious than us because they don't have the late recurrent processing, and this make their structure of the visual processing completely, or visual conscious process completely different from adults? Okay, I will just I will interrupt now for questions, and I did this conclusion for the overall theories as a slide. Okay, thank you.